So in this video, I'm going to explain what an infinite series is and how an infinite series can have a sum. We're going to look at how a geometric series and what that looks like. We're going to look at how to determine whether a series converges or diverges, and then whether it or not it has a sum, and how to figure out what that sum is in general infinite series, and then especially in geometric series. And then I'm going to introduce the harmonic series to you. So first we're going to start with what is an infinite series and how can it have a sum. So if we look at this square has an area of 1 unit if we multiply the 1 by 1. And we can see that if we break that square into little pieces, so we break it into a half, and then we break that other half into a fourth, and then we break that other fourth into an eighth, and that other eighth into a 16th, and so on. We can do this infinitely, and that area is still going to be 1 if we add up all those partial areas. We can see this here if we add the partial sums. We start with 1/2, and then we add that 1/4 and 1/8 and 1/16 and 1/32. We get closer and closer to 1. So that limit of that sum would be 1. That's an infinite series because we can go on with that indefinitely. So this summation formation represents that sum of an infinite series here, S sub n. So we take that sequence of partial sums, add them all together, and get that infinite sum. So for example, if we take that 1 that we just looked at, we start with 1/2, and then we add 1/4, which is 1 over 2 squared, add 1/8, 1 over 2 cubed, and so on, and we keep going indefinitely to infinity. Then we can start grouping and taking those sums and adding on the next one. So we're always taking 1 and are subtracting 1 over 2 to the n power. That's what we finally get. And if we take the limit as n approaches infinity of this amount right here, we get 1. So we can see that that limit of that sum as we approach infinity is going to be 1. If you get infinity when you're adding those numbers together, your infinite series diverges, or if it does not exist, then your infinite series diverges. So here's our first example of an infinite series, and we want to show that this one also equals 1. So to do that, we'll look at what is S sub 1. And that's 1 over 1 times 2, or 1/2. S sub 2 is 1 over 1 times 2 plus 1 over 2 times 3. S sub 3 is 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, and so on. We keep going. So S sub n is going to be 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4. And we continue on, always getting 1 over n times n plus 1. So if we use partial fractions on this right here, we get 1 over n minus 1 over n plus 1. And so we can rewrite S sub n as 1 over 1 minus 1/2, because that gives us that 1/2, plus 1/2 minus 1/3, plus 1/3 minus 1/4, and so on. So we can see that these are canceling out. This continues on till we get 1/n minus 1 times 1/n plus 1/n minus, or that's minus 1/n, minus 1/n plus 1. These are going to cancel out, and we'll be left with 1 minus 1/n plus 1. So if we do the limit as n approaches infinity of 1 minus 1/n plus 1, that's going to be equal to the limit as n approaches infinity of 1 minus the limit as n approaches infinity, 1/n minus 1. So this is just 1. This is going to be 0, because as this number gets bigger and bigger and bigger, we divide 1 by that huge number, we get closer and closer to 0. And so we've shown that that infinite series is equal to 1. We can show that this one diverges because s sub 1 would just be -1. S sub 2 is -1 plus 1, so it's 0. S sub 3 is going to be -1 plus 1 minus 1, so it's going to be -1 again. And S sub 4 is going to give us 0 again. So we can conclude that S sub n is going to be -1 if n is an odd number, like 1 or 3, and then if we went on to 5, and will be 0 if n is an even number. So if we did the limit as n approached infinity, because we're going back and forth and back and forth and back and forth, this does not exist. So this series diverges. So this gives us the idea. Here we can tell if this series converges or diverges by using, this is just adding up all the counting numbers. So if you remember, we had a formula for that in AP Calc AB, where I talked about the fact that if we add up counting numbers like this and then we add them up backwards, we always get the same sum. So we get the sum is 1 more than how many we added up. So if we do, and we get 4 of those, so, and that would be adding all those numbers twice. So I get n number of that number plus 1 divided by 2. That's how we add up all the counting numbers. So that's our S sub n. So if I do the limit as n approaches infinity of n times n plus 1 over 2, and I multiply that out, I'm going to get infinity for this because that number on top is just going to keep getting bigger and bigger and bigger. Divided by 2 is just, again, infinity. So this series diverges. So if you noticed in the past examples, those were all geometric series. Well, this is not a geometric series, but these two are geometric series because we have some ratio that we're multiplying by each time. In a geometric series, where we have some constant and then some ratio, and we keep multiplying that to the next power. So like we take the first term and then we multiply it by the ratio. And then we take that term and we multiply it by the ratio again. And we take that term and multiply it by the ratio again. That's a geometric series. Geometric series will converge if the absolute value of r is less than 1. So if r is between 0 and 1/2, or between 0 and -1/2, we'll have a geometric series that converges. And this is how we find the sum. We take that first term and we divide it by 1 minus the ratio. If the ratio is greater than 1 or less than -1, then that series is going to diverge. So if we look at all of these, we just have to find the ratio. We do have to make sure that it is in the correct form of a number times the ratio to k minus 1. So the summation form has to be in that form. This one is, and we can see right here that this is r, and this is a. So this is going to converge because r, the absolute value of r, is less than 1, 2/5. So we use that formula that we get a over 1 minus 2/5. So this is 8 over 3/5, which is 8 times 5/3, which is 40/3. Here, this is our r. We don't have an a, which means a equals 1. R is, absolute value of r is less than 1, because 5/9 is less than 1. So we have a over 1 minus a negative 5/9. So that's 14/9. 1 over 14/9, so we get 9 over 14 for that sum. Here, r is greater than 1, so the series diverges. Now, this one is not in the form that it needs to be, so we need to change this so that it is. So what we can do is make that 1/2 to the k power, because 1 to the k power is always 1, and so that we can make this 1 to the k, 2 to the k, and then we can pull out that k. Still not in the form though, because we need k minus 1. So to get k minus 1, that's going to be 1/2 times 1/2 to k minus 1. This is the same thing as this, and now we have it in the correct form where r is 1/2, so this converges. And a is 1/2, so we get 1/2 over 1 minus 1/2, which is 1/2 over 1/2, which is 1. This one's also not in the correct form because we have a 0 down here and we need to start with 1. So we need to change this This is the same as k equals 1 to infinity of 1/3 to the k minus 2 power. We don't want k minus 2, we want k minus 1. So this is the same thing as 1/3 to the negative 1 power times 1/3 to the k minus 1 power. So this is our a, or 3 is our a, and this is our r. So this converges. And we have a over 1 minus 1/3, which is equal to 3 over 2/3, which is equal to 3 times 3/2, or 9/2. Finally, this last one, we have this is correct, but this part we have to work on to make it r to the k minus 1 power. So if we look at this, this 10 to the k plus 1, this top part, is equal to 10 squared times 10 to the k minus 1. 9 to the k minus 2 is equal to 9 to the negative 1 power times 9 to the k minus 1 power. And so that's the same as 1/9 times 9 to the k minus 1 power. So we can rewrite this as 100 from our 10 squared times 10 to the k minus 1 over 1/9 times 9 to the k minus 1 . 100 over 1/9 is the same, is equal to 900. And then we can take that 10/9 to the k minus 1 power. So now we have it in the form that we want. This is our r. The absolute value of r is greater than 1, so that series diverges. To write a repeating decimal as a quotient of two integers, we can use an infinite sum for that. So this decimal is the same thing as 0.09 plus 0.0009 plus 0.000009, and so on. We can keep going like that. Write that as fractions. That's 9/100 plus 9 over 10,000 plus 9 over 1,000,000, and so on. Pull out the 9 over 100, and we get 1 plus 1 over 100 plus 1 over 10,000, and so on. This is 1 over 100 to the k minus 1 power. k equals 1 to infinity. So now we have it in the form that we need. This converges because that's 1 over 100. So r is 1 over 100, a is 9 over 100. So we have a over 1 minus r. This is 99 over 100. So that's 9 over 99, or 1/11. So now we know that 1/11 is exactly the same as this repeating decimal here. In this problem, we have a ball dropping from a height of 12 meters. So what happens to the ball is we drop it, it goes down 12 meters, and then it bounces back up 3/4 of that distance, falls that same distance again, bounces back up 3/4 of the previous distance, falls that amount again, and so on. So we have a geometric sequence where 3/4 is r, 12 is a, it's its starting height. And so if we define h as being the total distance, that is equal to the original height plus 2 times that second height plus 2 times the third height plus 2 times the next height, and so on. So we can write that as the original height plus 2h sub k. We can rewrite that as (12) for the original height and then we know that we have 2, our original height is going to be 12, that's our a, our r is 3/4 to the k power. Now this isn't in the form that we need because it's to the k power, so we need to fix that. We can also multiply this 2 times 12 to get 24, and then we can do 3/4 times 3/4 to the k minus 1 power. So if I take 24 times 3/4, I get 18. That's our a for the formula. And then we have 3/4 to the k minus 1 power. So now we have it in the form we need. R is 3/4 and a is 18. So we do 12 plus 18 over 1 minus 3/4. This is 18 over 1/4. So that's 18 times 4, which is 72. Adding those together gives us 84 for the total distance that the ball travels. A harmonic series is another series that continues on infinitely. A harmonic series is when you take 1 and then you add the fraction 1 over 2, and then 1 over 3, and 1 over 4, and so on and so on and so on. And so if you write it in summation form, it's k equals 1 to infinity of 1 over k, because this is a 1 over 1, and that is going to always diverge.